Hello. This will be a brief tutorial on how to convert from binary numbers into decimal. And it's a fairly straightforward process, and this tutorial should be fairly short. So let's get going. First, just a brief outline to show what we're going to do. First thing is I figured that we should start with the known and then go from there into what may be unfamiliar. So just to show how counting is done, or the basics of counting in any base, whether it's base 10, decimal, base 2, binary, or base 16, which is hexadecimal, that we can, it uses the same principles, and we'll demonstrate that with the decimal counting. From there, I will go and show an example of just binary counting and how the same process would be done with binary, or basically two numbers, 0 and 1. From there, we will look at an equation that can be used and for converting from binary to decimal. And this is actually a generic equation that can be used for converting from any base to base 10 or decimal. But in this example, we're only going to work with base 2. Here, using equation, I have handwritten the equation specific for base 2, and we'll walk through an example of doing a conversion. And then here, just to prove that my calculations are correct, we'll take the results and compare it to basically a conversion table that I put together when I do the binary counting. And so we can confirm that, yeah, the two are really the same. So let's get started. Okay, if we look at decimal counting, you'll see, and you probably haven't looked at it this way since you were in elementary school, or if you're much younger, I think there's different ways that this is done now, but this is basically how I was taught. Is that with counting, we have columns. The first one is what I'm calling here the 0 column, and it would have the numbers 0 to 9. And values can't get any bigger than 9. If we go over to the next column, these would be the tens column. And there, again, they would go from 0 to 9. 100ths column would be the next biggest numbers, and they would go, again, 0 to 9, then there's the thousands, and then we could go 10,000s, 100,000s, and so on and so forth. So, and simply counting is no more than taking a value, say 0, and adding 1 to it, which would give us 1 in this case. If we were going from 1 to 2, all that we're simply doing is that we're adding 1 to the existing 1, and that would give us 2. So counting, we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And at 9, that's the largest number, we would put a 0 here, and we would carry over to the next column, which is the tens column, so that gives us 10. Of course, the next number would be 11, and from there we could count up 12, 13, 14, all the way up to 99. That's the highest number, at which case we would have to add 1, which would go over to the next column, which would give us 100, and those would go to 0, and then of course the next value would be 101. So straightforward, something that you probably do without even thinking about it. Now, how would we do that in binary? Okay, so in a chart here, we have our binary. And in binary, again, we have columns 0, 1, 2, 3. And I'll label it this way just because that this is going to make it more conducive for using this in the equation. But the first column is going to be the lowest order of magnitude, and it can only have the values of 0 and 1. As you see in the counting here, we go 0 and we go 1. Once we go to 1, we have no other number. We're at the end of our list, so if we add 1 to that, and if we did a little bit of binary counting, we have 1, and we add to it 1. Well, in decimal, that would be 2, but since we don't have a 2, it would be 1, 0. And that's what we have right here. So this is 1, 0, and of course you can see the conversion to 10 would be the value of 2. So from there, we go 1, 1. And then here we have the same issue. We can't go any higher than 1, 1. So we go over to the next column, add a 1, and then those become 0, 0. So then we have 101, and then 110, then 111, which would be 7. Then here, once we add one more, we come over to the column 3. And we go from there, and we just keep adding. So that is binary counting, and I only went over 3 columns. Of course, you can go over many columns, but continuing on, this is the equation for converting from basically any base, which is why I put it this way, to a decimal value. And what we do is that I is the column. So we start with column 1, the column 0, and then whatever the value is in column 0, that's what this X represents right here. And then it's going to be multiplied times the base to whatever that column number is. So this, and if you're not familiar with this summations, this simply says that I take whatever this value is here, and if there are multiple columns, then we're simply going to add those together. If I had an example of like 1, 1, then the way that this would be applied is that we start with column 0, which is going to be 1, which is the value, times the base is 2, and the column is 0. And then, because this is a summation, now we're going to add that to the next column, which would be the column 1. So that would be 1, which is the value that's there, times 2 to the 1. And what I wanted you to see here is that this is just the summation. In this case, we start at 0, and n is 1, because that's the maximum number of rows. All right, let's go to another example. Okay, here's an example. And what we want to do here, I have already written in the equation, and it's specific to base 2. And in this case, we could actually, let's say, erase this in here, and we could put in 3. Oops. Okay, we could go here, and we could put in 3, because 3 is the highest column that we're going to go to. Now, our example that I have right here is 0, 1, 0, 1. And then right here I put down the columns just so that we could see them. Column 0, column 1, column 2, column 3. So if we start doing the calculation, we're going to start with column 0. It's a little different, I understand, because we're going from right to left instead of left from right. But the value for column 0 is 1. And then that's times 2 to the 0 column. And then we have plus. And the next one in our summation would be value of 0 times 2 to the 1. And the next one is going to be the second column. And the second column has a value of 1 times 2 to the second power. And then the last one is a 0. So we have 0 times 2 to the third. So to calculate those out, we said that 2 to the 0 power is 1. So we have 1 times 1 plus 2 here would simply be 2, but times 0 is going to be 0 times 2 plus 1 times 4 plus 0 times 6. So if we break that down, we have 1 plus 0 plus 4. 1 times 4 is 4 plus 0. And that gives me 5. So the decimal equivalent of 0, 1, 0, 1 is 5. Right here. So now let's look and compare this value to our conversion chart to see if they come up the same. Okay, we want to look at these just to see if they are the same, and as we can see here, our calculated result was 5. And if we go over here, the converted value, the binary value was 101. And it's 5, so this shows that the calculation indeed came up with the same value. This concludes how to convert from binary to decimal. Hope you enjoyed it. Hope that you maybe learned a little something that will help you in your career, or at least understanding of how computers work. And please look for more of these educational videos. Thank you very much and have a good day.